A long time ago, way before I was born, people who were inventing the first browsers decided that the SVG and XML file formats were, for some weird reason, going to be able to execute JavaScript in the victim's context. And now, flashback to the day, and I'm getting paid $10,000 for an SVG cross-site scripting vulnerability that is still haunting developers to this day because of these two really weird file formats that can do these crazy things for whatever reason. I mean, who decided that XML could just read files on your computer, right? But anyway, as the title suggests, I'm going to walk through an S3 misconfiguration vulnerability where basically the victim server is going to proxy to the S3 bucket, usually through a CloudFront configuration, and then that's going to lead to cross-site scripting through an SVG or XML upload. And first I'm going to show how the vulnerability works, and then I'm going to go into kind of the configurations on the CloudFront side and how you're normally going to be able to identify these type of situations. As always, the lab is actually available, so you can go onto labs.yagsec.com into the demo labs, and the lab is called Cloud SVG XSS. So, you might as well pause it here and go try out the lab yourself, see if you can find the vulnerability, and then basically come back and watch me solve it. So we'll jump straight into it. So this is the lab right here, and we're going to be looking at, this is pretty simple little application here. And this is like pretty commonly like some kind of like random settings page. You go into like avatar settings, like this literally exists in like every application on the planet. You can put a profile picture or like put a username or whatever. And it just commonly is going to look like this. And a lot of the times it's going to be proxied to some kind of cloud storage system, cloud storage environment that is being used by the application. And a lot of the times, not always, a lot of the times it's going to be basically AWS or it's going to be Google Cloud Storage, which I've talked about before, but they're basically the same thing. Very limited amount of times you're going to see something like Cloudinary, which works a little bit differently, but it has a few different types of vulnerabilities that are distinct from S3. Anyway, we'll just jump into the flow. So you can see we're going to be able to choose an image. We can go in here and we're basically just going to upload it, and it's going to upload the avatar and it's going to load it into the DOM. So you can see how it's loaded in. As we expect, it's going into some kind of S3 bucket, right? We can hover over it. There's the image and it's loaded as an image source, right? We can like change our username as well. I don't know, I guess I'll call myself Yagsec. There you go. Call myself Yagsec. Well, obviously this is all boring. We want to see what's actually going on in the back end. So let's just come up here into our HTTP proxy, and you can see a couple of things. See the first thing. So this is presumably a course pre-flight check. If you don't know what that is, then go watch the course video. This is the request that actually goes into the S3 bucket. You can see in this case, the bucket is public. Like obviously it's not going to be usually public. So in between this, there's probably going to be another step where the person fetches a pre-signed URL. So presumably this is like a pre-signed request, but I just wasn't asked to do that. So that's going to be like a pre-signed request. Then a lot of the times what happens is there's like a syncing step, because the server usually doesn't like talk directly to the bucket, because that kind of defeats the purpose a lot of the times. So the client usually supplies the key, or supplies like the name of the key, say like the CUID or whatever, and that's basically decides where the server is going to get the image from. Either that, or it's actually generated by the server during the pre-sign process. So the server gives you a pre-signed key, where then the key comes from the key that the server actually generated, which is the more secure option usually. And then the client can get the image and everything works fine. And then the server has it saved so that every single time the user loads, it will fetch the exact same key. So that's basically where the syncing happens here, where the client and the server are directly in sync. So that's basically how that works. Now, the thing that sometimes happens here is that companies don't like having these S3 buckets directly exposed, right? Number one, they don't want them directly exposed. And number two, it looks a bit unprofessional to have like an S3 bucket link directly in their like sort of DOM and stuff. And it can also conflict with content security policies, because if they, for example, want to put a content security policy down, they can't put an S3 bucket link directly. Like they can't allow all the S3 bucket domains, because that would defeat the point, because an attacker can create an S3 bucket, right? So they would have to actually put the S3 bucket down into the content security policy, But then that would like leak all the S3 bucket names to anyone who gets that content security policy, which can be an issue. And then also like if they want to change the name of the S3 bucket, then it's like really annoying because then they have to like go in and then change the content security policy, or like everything will break. So sometimes there can be like issues with some of these things. So sometimes they prefer having it on their own domain. So they prefer proxying the S3 bucket to their own domain. And normally that's something that they use CloudFront for. So CloudFront, I mentioned before, it's this like CDN. So it's like a distribution network for companies, and they basically use it to front certain kind of resources. It used to just be used for distributing static files, but now it's kind of being used for everything. So in a lot of ways, you know, CloudFront is just actually the main reverse proxy you will meet when you look at most websites. The actual route that you land on is almost completely going to be decided by CloudFront for a lot of companies. So we're going to take a look at that now. We're going to refresh the page first of all. We'll come here, we're going to refresh the page. You can see the avatar persists, so there's some server-side storage going on. When we refresh the page, we're going to find just this main request right now. Now we're going to send the request into the repeater. So we're going to click on the repeater, send it in, and we're going to just view the request here. So I'm going to get rid of these really annoying Express.js matches. This obviously isn't running on CloudFront, but if it was running on CloudFront, you'd see something like server CloudFront here, which would tell you that it's running CloudFront as a reverse proxy. And the way CloudFront works is the person can configure like behaviors for certain directories. So most of the time you'll see that if we put like test here, the routing is actually going to go to this Express.js application. We know it's Express.js because of this right here. And this is like very commonly used in Express.js apps. When you see like this cannot, and then the method, and then the path, that's almost always an Express.js application in this format. So we know it's some kind of Node.js app. And we know that like other paths, it will type in something else, and it's all getting routed to the same Next.js application. So that means it's kind of like a catch-all there in behind the CloudFront proxy. But certain directories, like this assets directory that you might have caught when you were fuzzing this, get routed to a different backend. And you'll commonly see this with something like API. API commonly goes to some kind of different backend. Assets, you'll see like static or something like this. You'll see these things routed to different areas, and that's all been done doing CloudFront, usually, or a reverse proxy or whatever. And that's basically what you'll pretty much always see. And in this case, we have this assets directory. Now, the way this assets directory usually works is it's actually going to front some kind of S3 bucket, basically. So that you can configure this in CloudFront, where the CloudFront basically instance automatically will get credentials to the S3 bucket, which means you don't have to configure authorization, which is really very helpful. And basically it's used primarily for static assets. When you want to hold like a JavaScript file that's not going to change, you put it into this like assets directory in your own page, and then you front it with CloudFront, so that basically you can serve it from your own domain, basically getting rid of all those content security policy issues. In this case, sometimes companies will also use this to proxy through user-generated content into their own page. And this is where a lot of the oopsies can happen, which is where, if you remember that image file that we uploaded, so we uploaded this image file, if it, for example, got served from our CloudFront domain, if we went over here, if it got served using an S3 bucket, we could potentially fetch that image file basically from our own system here. And that's basically what we're going to use. So you can see that there's no like sandboxes by default. So S3 does not sandbox any files by default, and it doesn't sanitize any files either. So we can basically send whatever content type we want to into S3, and it will just get directly served back to us. And normally what will happen is that you'll get a pre-signed URL, but the pre-signed URL does not constrain what content type you can send. Now this is the important distinction, right? So by default, there's no content type distinction. There is a limit on what key you can send into. So you can send arbitrary keys, and that's generally it usually. And obviously the method is constrained, right? So if you get a get, you can't do a post, right? But if you do get a post, a lot of the times the content type will not be pinned, especially in S3. If you don't specifically see like the header inside of the pre-signed URL, where inside a policy like this base64, it will say content type. If you don't see that, you can send whatever content type you want to into the S3 bucket. So if something is fronting the S3 bucket, then you can basically put whatever content type you want and the application will serve that. So we're going to try it out now. This is obviously, just as an example, it's a public S3 bucket just so we can see. Well, we're going to look over here at this application here. So we're going to get rid of this PNG and we're going to just change the content type to say HTML. And we're going to put an HTML string. We're just going to put a script down, right? And this should land on the S3 bucket. Now, getting XSS on an S3 bucket is pretty shit, to be honest, most of the time, because it's kind of like a sandbox domain, right? People expect there to be like random files there. Well, if you can promote that to cross-site scripting on the main app, that's where the vulnerability can start. So we can go try and fetch that again, right? And now if we fetch it again from the assets directory, we should see our content getting served, right? And this will execute inside the browser. So we can actually repeat this ourselves in the browser right now by going into here and just fetching that. And you should see that we have executed on the main domain. I don't know what that is. Anyway, you can see that we have execution on the main domain. So that's the main thing I wanted to show you. And that was the vulnerability in this lab, that basically the creators, like, they created this kind of front for this S3 proxy. So they created this S3 proxy and then they didn't sandbox it. Now, what will limit the execution here? So what will limit execution is two things. One, a content security policy. If there's a content security policy, then, you might have to work around it or try and bypass it. That will usually limit execution. The second thing is content disposition. So for these kind of assets, you'll get this header called content disposition. When the content disposition is set to attachment, then the browser will not execute the script, but it will download it as a file. So that's sometimes what can happen, is that the content disposition header will prevent you from escalating these vulnerabilities to cross-site scripting. The third thing is the specific content security policy called sandbox, which makes the browser basically not execute the script, which is something that you will also see. So those are generally the two defenses. And obviously, if they pin the content type on the pre-send URL header, then sometimes that can also prevent cross-site scripting. Although that I would say that's probably a bit weaker because you can probably use another feature to try and escalate there. So that was the vulnerability that I found on this app, which is I found this basically assets directory and I found that it was tunneling directly to this S3 bucket. And from there, I was able to fetch my own asset, which was in this case an SVG. And I was able to basically upload the SVG and I was able to get XSS, basically the same way that I did here. And just to show you how that might look in a configuration on the backend, this is often what it's going to look like. So I remember I used this for the CloudFront misconfiguration video where I was using like this plugins directory. This is often what they do. So whenever, say, you want to configure your own assets directory, what you would do is the developer would go here into create behavior. They would basically select here, they'd select one of the pre-existing options, something like assets, images, static. They would click that option. They would click their S3 bucket. And that's literally all it takes for the vulnerability. The vulnerability now exists because if this bucket accepts user content, that's basically how we're going to be able to serve it from. So they just have to click here, create behavior. And now the reverse proxy will now serve that assets folder. It will now serve the S3 bucket from there. So that's literally all it takes for that vulnerability to exist, which I think is pretty cool. If you enjoyed the labs in this video that I was walking you through, then you might also enjoy my other labs. These are like my community and labs package that you'll see in the description. And it includes these like 12 very cool labs that I've documented here. Especially these LLM ones are very fun. So if you enjoyed those labs, then if you want more, then you can go check out the link in the description and consider supporting me that way. And yeah, I hope you enjoyed this video covering a cross-site scripting vulnerability that I managed to achieve through one of these S3 configurations. Honestly, one of my favorite class of vulnerabilities now is actually getting cross-site scripting through misconfigurations on the server side, just because many people like forget that client side exists. When they look at these server side things, they're thinking about, oh, we need to secure, we need to get rid of these path traversals, we need to, we need to sanitize this for like template injection or something. And then they completely forget that the app is like serving things back to the clients. The client is reading it. Maybe it's like JSON, and then there's like prototype pollution or something inside of it. And that's honestly very cool and a very cool attack scenario. And I think I've been honestly having a bit of success with it, especially when it considers like third-party services and infrastructure. Something that, you know, I talk a lot about on this channel, but something that I've just really enjoyed doing in general. And I've been having success with it. So I just wanted to share a little bit with you guys about it and some ways you can kind of get started looking at these things and doing your own research on it. That's it for me. Thanks for watching and happy hunting.